So first let's go over some vocabulary. A transformation is a change in the position, shape, or size of a geometric figure. We're going to be looking at two types of transformations. We're going to be looking at translations and reflections. Now we're going to refer to things like pre-image and image. The pre-image is the original figure, and the image is the resulting figure. Now the first transformation we'll be looking at is a translation, and a translation is a transformation that maps all points of a figure the same distance in the same direction. You can think of translations as sliding a figure. So when we slide, we can slide figures up, we can slide them down, we can slide them left and right. So now we're going to talk about how we write transformations, how we notate it. So a transformation maps a figure onto its image and may be described with arrow notation. Prime notation is sometimes used to identify image points. In the diagram below, K prime is the image of K. So here's our initial image, triangle JKQ. And triangle JKQ is being mapped onto, so this pre-image is being mapped onto its image, so triangle J prime, K prime, and Q prime. And we read this arrow as maps onto. So this slide is just making sure that you understand how to represent a transformation using symbols. Alright, so the first thing we're going to do is find the image of a translation. Now, finding the image is actually not so bad. Remember, a translation is when we slide the pre-image. So our pre-image over here is in black, and we see that because these letters A, B, C, and D, they don't have the primes. So the primes are the image, and without the primes are the pre-image. So I'm going to write that on here. So here's our pre-image, and here's our image. So since all we're doing is sliding, we just need to count. We're going to pick a point. I'm going to pick B. And I'm going to count over and then up or down to get to B prime. So I'm going 1, 2, 3, 4. So I went to the right 4, so I went positive 4. And then I'm going down 1, 2 to get to B prime. So negative 2. So that's all I would do to slide my pre-image to my image, is I would use that same pattern to the right 4 and down 2 for each of my pre-image points to get to my image. To write that rule, since moving to the right and to the left deals with our x-axis, then our rule would be x plus 4, and our y, since moving up or down deals with the y-axis and we're going down, it would be y minus 2. So now when we go and look at this example down below, where it says, what are the images of the vertices of triangle PQR for the translation? And then it says the coordinates x, y are being mapped onto, and this is how they're changing. So the x coordinate, it's minus 2, which means we're going to go to the left 2 units. And then the y coordinate says y minus 5, which means we're going to go down 5 units. It says graph the image of triangle PQR. So all we need to do is take each of our points, P, Q, and R, and shift them, translate them, slide them, and this is our rule for it. So for each point, and I'll start with P, I'm going to go left 2 because I'm subtracting 2. So 1, 2, and I'm going to go down 5. 1, 2, 3, 4, 5. So this point right here is now P prime. I'm going to do the same for Q and R. I'm going to use a different color here. Let me change this out. Okay, so for Q, I'm going to use the same rule. I'm going to go left 2, 1, 2, and down 5. 1, 2, 3, 4, 5. And so this point is Q prime. And one more time. with R, I'm going to go left 2, 1, 2, and down 5. 1, 2, 3, 4, 5. And now I found R prime. So if I want to graph the image of triangle PQR, the image is going to be triangle P prime, Q prime, R prime, and I'm just going to connect my points here. And I've drawn the image. Alright, so you try. Do the same thing. Here's your rule here. The coordinates x, y are mapping onto x plus 1 and y minus 4. So think about where this plus 1, if it's going to shift you left or right, since it's with the x. And the y is going to be up or down. Think about what the minus is going to do. Go ahead and pause this and then continue on to the next slide. Alright, on this slide, we're going to look at our objective that says writing a rule to describe a translation. And I think since we just looked at rules and we were able to apply them, that writing the rule is not going to be so bad. It says, what is a rule that describes the translation PQRS maps onto P prime, Q prime, R prime, S prime? So all we have to do is we'll start with P, and we have to see how far left and right we go over, and then how far up and down we go over. So we can go ahead and even start our rule. We know it's saying for each ordered pair, x, y, it's going to map onto, and then here's our rule. We're going to have x, and then plus or minus something, and y plus or minus something. And again, all we have to do is count. So P to P prime, we know we're going to the right. And when you go to the right, that's going to be plus. So x plus. And now let's just count. 1, 2, 3, 4, 5, 6, 7, 8. So x plus 8. And then now I just have to go down, and going down is going to be minus, up would be plus, and we go down 1, 2. So minus 2. And just to make sure that we are right and we didn't count wrong, we could check our other points. So if I started at Q and I want to go to Q prime, I just double check my rule. Am I going 8 to the right? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yep, so I know that one was right. And then am I going 2 down? Let's see, 1, 2. Yep, so that one was right. So here's our rule. Here's our answer. We could check the other two just to make sure, but I feel pretty comfortable just checking 2 of them, and if I had the same rule, then I think I'm good to go. Alright, so now it's your turn. You try. Just so I just noticed this picture is kind of blocking some of these words right here. So let's see what they were supposed to be. The translation image of triangle LMN is triangle L prime, M prime, N prime. I think that word is going to be with. And then it tells you the ordered pairs of L prime, M prime, and N prime. So notice in your picture over here on your graph, you only have your pre-image. So you might want to graph this pre-image and then also graph the image. So then you can count like we just did. Or your question says, what is a rule? And then the word that go before here. So what is a rule that describes the translation? Okay, so again, my hint to you is to map or to graph both the pre-image and the image, so that way you can do this problem just how we did it on the slide before. Okay, pause this before you continue on. The second type of transformation that we're going to look at is a reflection. Now this says, the size and shape of a geometric figure stay the same when you flip the figure across a line. Its orientation reverses. So we looked at translations, and again, we're just going to remember translations. You can think of it as sliding a figure. Now we're going to look at reflections, and you can think of this as flipping a figure. So in this key concept, it says reflection across a line R is called the line of reflection. Line R is. This is a transformation with two properties. One, if a point A is on line R, then the image of A is itself. So notice here's our line of reflection that we're going to flip over, but since point A is on that line, then its image will also be on that line. And then if a point B is not on line R, so notice point B is not on line R, then R is the perpendicular bisector when you draw the segment B, B prime. So that just means that if you were to connect the line going from B to B prime, that it would be perpendicular to line R. It would create this right angle here, and it would be equal distances away, which is what our hash marks or our tick marks are showing us. All right, so let's look at example 1, reflecting a point across a line. So point P has coordinates 3, 4. So let's go ahead and plot that. 3 to the right, 4 up. So here's point P. Our directions say graph point P and the line of reflection y equals 1. So the line of reflection y equals 1, if you recall, y equals a number is going to be a horizontal line, and x equals a number is going to be a vertical line. So just keep that in mind. So y equals 1, I'm going to graph that with a different color. Y equals 1. Here we go. Alright, so we want to reflect this point across the line. Since we're reflecting, and we know reflecting means to flip, well, point P is above the line, so we know point P prime will be below the line. What we need is to have point P prime the same distance away from the line of reflection as point P. So let's count that distance. P is 1, 2, 3 units away from the line. So I know P prime will also be the same distance, 3 units away. So I'm going to count 1, 2, 3, and P prime will be right here. So P prime is at the ordered pair. Let's count that 1, 2, 3, and then down to 3, -2. So here is our image for point P. All right, let's look at our next example. It begins by saying graph y equals x on the coordinate plane. So let's recall slope-intercept form is y equals mx plus b. And if we want to graph y equals x, well, our m, our slope here is 1. That's the coefficient in front. And our b, our y-intercept, since it doesn't exist, is 0. So I'm going to start at 0, and my slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. I'm going to draw the line y equals x. All right, so we did that. Now it says reflect point A, here's point A, across y equals x to graph A prime. Fill in the blanks with the coordinates of A prime. So this one's actually just as simple as the last one. Let's go ahead and find where A is. A is at 1, 2, 3, 4, 5, and then down 1. So A is at the point 5, -1. So our rule, our general rule, when we want to reflect a point across the line y equals x, we could write our rule like this. Our ordered pair xy is going to map onto y comma x. So notice all we did was switch our ordered pair. So again, anytime you need to reflect a point across the line y equals x, you're just going to switch the ordered pair. So our ordered pair was 5, -1. So A prime will be at -1, 5. So we'll plot that -1 and then down 5, 1, 2, 3, 4, 5. So here's A prime. All right, here are your last 3 U-Try problems. So go ahead and try all 3. Make sure that you took great notes, that you copied down all of the example problems, all of the notes, and that you have all of the U-Try problems. All right, thanks y'all. I'll see you in class.